or rather the sign of delta S surroundings, depends upon the enthalpy of the reaction, the change in enthalpy of the reaction, delta H reaction. Depends on whether or not that's positive or negative, because that determines whether a reaction releases or absorbs heat, determines whether or not the surroundings gain or lose entropy. So it's all tied together in a chain. The delta H reaction determines delta S surroundings determines delta S universe, and delta S universe determines spontaneity. Predicting and calculating entropy changes. Consider this question along with a diagram of oxygen, hydrogen, and water molecules. Question 3 asks, does disorder increase or decrease for the formation of gaseous water, as we see in this reaction here? If you remember this question, it had the diagram with the H2 and O2 molecules on the left and the water molecules on the right, and we answered that since the number of particles goes down, the amount of disorder goes down. So in the balanced equation, no, this is just basically a new way to look at the same kind of equation, because we've got our H2 here and our O2 here, and it's going to H2O. So instead of looking at it as a diagram, we're looking at it as a balanced equation. So we have 3 moles of gaseous reaction here, 2 from the H2 of H2 and 1 of O2, so that's total 3 moles, and 2 moles of product, which is the water. This illustrates the general principle that whenever the number of moles of product gas is less than the number of moles of reactant gas, entropy decreases, and vice versa. More tedious questions. Explain why delta S is negative for the following reaction. Well, okay, there's solid here, a gas here, and a solid here. 3 moles on this side and 2 moles on that side. So as we can see, the amount of moles of gas is going down. And the moles in general is going down, but moles of gas also decreases from 1 to 0. So the phase change, the reaction that's going on here is taking 2 moles of solid and 1 mole of gas and changing it just into 2 moles of solid. So the answer is going to be yes, because amount of moles of gas, which is a highly disordered state for something to be in, is going down. Therefore, disorder is decreasing. Disorder is decreasing because the total moles of gas is decreasing. Or, you could also say it, order is increasing. For each of the following reactions, predict if the entropy change is positive or negative. If you cannot tell, explain why. Well, let's look at the first one. The total moles of gas is decreasing. There's 3 on this side and 1 on this side. Therefore, there's more order on the right side, and entropy is decreasing because order is increasing. Less moles of gaseous reactant is left. For the second one, total moles of gas goes up from, I forgot to put the arrow in. The arrow should go right here. The arrow should be right here. Number of moles of gas goes from 1 to 3, therefore the entropy change is positive because there's more disorder. Third reaction, the arrow should be here, but I didn't put it in again. So it's 2 moles of gas on this side and 2 moles of gas on the other side. There's no net reaction increase or decrease in number of moles of gas for this reaction, so it's impossible to tell. Entropy values can be calculated in much the same way as enthalpy values. Using a table of standard entropies, calculate the entropy change for the following reactions. N2 and O2 gas react to make NO gas. Standard entropy, using the table, you can get these values pretty easily. N2, O2, and NO. The formula to use for the delta S of reaction is delta S of products minus delta S of reactants. So substituting in these values, we get a delta S reaction value of 24.8 joules. Note that the number of moles is important in the entropy equation. It is 2 to 10.65 because there are 2 moles of NO. These two don't have any coefficients in the actual reaction itself, so they don't have any coefficients here. But this has a coefficient of 2, so this also has a coefficient of 2. Look at this reaction. Let's take a look at this one. Alright. Same formula, same deal. These values are the standard entropies of